here's this rectangular prism. I'm gonna go by that. We found the volume. We took the volume, saw how many times bigger. We multiplied 2 times 4, which is, 2 times 2, which is 4, times 3, which is 12. It got 12 times bigger. You multiply that times 12, you get this. Put it over that, you still get 12 times. 3 times 1 times 2 gives you 6. Multiply by 6, you get the new volume of this. Divide the 2, you get 6 times bigger. Same thing there. Okay, on the back. What conjecture, what statement can you make regarding the effects of changing dimensions on volume? So what can y'all say? When you change the length, the width, and the height, it gets bigger, or it can get smaller, and we'll talk about that too. Okay, so let's go to example 2. Suppose the volume of a right triangular prism is, so they give you the volume, equal to 360 units cubed. What would be the new volume if one dimension is twice as long, so times 2, right? The second dimension is 3 times, so times 3. And the third dimension is half as long, so times a half, right? Half. So how many times bigger does this one get? It gets 3 times. 3 times 2 is 6, right? Times a half, or take half of 6, you get 3. If you want to put that in your calculator, you can. 2 times 3 times a half, or 0.5. You should get 3. Well, what is 360 times 3? You got it. Say that again. 1,080, is that correct?
Yes.
Units cubed, that's your new volume. Okay, so that's what it's looking for there. And then suppose you take the volume, so here's your volume of 54 square root of 3 centimeters cubed. There's your volume. The new volume, one dimension is half, so I'll just put it out here, times a half. The second is double, times 2. And the third dimension did not change. That means we're multiplying by what?
1.
Okay, how many times bigger did that get? None. That's just multiplying by 1. If you multiply all those together, that means 1. So it's going to stay the same. And that's it.